Now, for 1.1, introducing calculus, which is can change occur at an instant rate, right? The idea is the rate of change, that means slope. So we are using that slope formula. In calculus, though, instead of finding the slope between 2 points, we want to find the slope at a point. So what that means is we want to have the 2 points, or the 2 point closest to the point that we want to find. So for example, if we want to find the slope at 1, then we want to use a point closest to 1 as much as we can so that we can get the slope. So in this case, we can try 1.4, we can try 1.3, but if we have the point 1.05, then we can use that. Okay? Also understand that if, let's say, for example, given a function, and I want to find the slope at that particular point, in this case at 4, you really want to pick 2 points that are closest to 4, or in this case, you want to pick 2 points that not only closest to 4, but 4 is somewhere in between there. When we say in between, that doesn't mean it has to be in the middle. It just has to be in between there. So in this case, the best choice is when you look at the point 3.8 and 4.2. So if I want to find the slope, right, connecting that point between, I want to find the slope between these 2 points, then eventually I can find the slope at that point that I want, which is 4. So the key idea is, if I want to find the slope at a particular point, make sure you choose the 2x value where that point is in between and closest to it. Questions on that? Right. Same thing here. This is the last example that we have. If I want to find the velocity at 7, know the position measure length. Velocity measure the rate of change between length and time. So feet over second or meter over second. So if you want velocity given position, which is this graph, you want to take the change in y divided by the change in x, which will give you velocity. You want to find 7, then pick the 2 points where 7 is in between. In this case, you can pick 6 and 8. Now, can I pick like 6.9 and 8.1? You can, but you can see that it's going to produce the same slope because it's on the same line segment. Do you guys see that? Yeah? Any question on that? Now, we're going to go straight into the practice. This one is 1.1, and this is on the AP College Board. They ask you for number 1, go ahead and I'll give you time to read that, and then let's see if you can do that one yourself. So go ahead and read that. The site population of bacteria is modeled by the function p, where p of t gives the number of bacteria and t gives the number of hours after midnight. So let's underline that. P of t tells you the number of bacteria. T is the number of hours. So this tells you the y, and this tells you the x, which is the t there. And the hours is after midnight from 0 to 10. I want to graph the function, the graph of the function p, and the line tangent. Let's underline the word line tangent for me, please. And the line tangent, bless you, at t equal to 8 are shown above. which of the following give the best estimate for the instantaneous rate of change of P at 8? So rate of change we know is the slope. Instantaneous means the slope at that particular point, at that particular value in time. Is that good? Now, I want you to associate slope, rate of change, instantaneous rate of change, and line tangent together. Instantaneous rate of change in calculus tend to relate to line tangent. So make sure in the future when you see the word line tangent, you know they're talking about instantaneous rate of change. Okay? So what I want to know is, here's my point. That is the point at A. What is the slope right here? Well, if I were to look at the slope, this is not the slope. That's the y value. So this is out. Okay, this is the y value at x equals to 8. Yeah? Emmanuel, number 5. Okay, that's your slot. And then get your packet. I don't want to use B because I have to go from, I'm using point 0 and 8. So if this is point 0, right, and this is 8, if I were to draw the secant line, do you guys see that this slope is not the same as the one that I want to find? You see that? So that's out. The slope of the line joining 0 and 10. Well, 10 is up here. So again, one more time, if I were to draw my secant line in this case, you're going to see that this slope and this one, they're not the same one. So I want this tangent line. So this is out. If I were to look at 7.9 and 8.1, so this is 8, so 7.9 is here, 8.1 is here. So if I were to draw the slope between these 2 points, yes, that would be the best estimate for the instantaneous rate of change at 8. Questions on that? Okay. All right, go ahead and we're going to stop now. And then what we want to do